This is section 7.1, which is solving systems of two equations. We're going to talk about substitution, elimination, solving systems graphically, and applications. So a solution of a system is an ordered pair where those two equations meet. So graphically, if you have two lines, the point where the two lines intersect is the solution to the system of equations. We're also going to look at situations where you might have like a quadratic and a line. So you might have two solutions to your system of equations, but you're writing your solution as an ordered pair. That would be a solution to each equation. Okay, so example 1 says to use the substitution method. I have a problem with this because this system of equations is not set up for substitution, and I feel like at this point you should be able to choose which type of solving makes most sense for each individual problem. So I will do this one by substitution, but I'm also going to show you elimination as an example on this one as well, because I feel like that would be an easier method. So substitution works best if you have an isolated variable, which we don't have in this case, so we need to make one. So if I rearrange the top equation, I'm going to add the y to the right side, and I'm going to subtract 10. So we could say 2x minus 10 equals y. Then I can take the 2x minus 10 and I can substitute it in for y in the second equation. So that would give me 6x plus 4 times 2x minus 10 equals 1. Now I have gotten rid of the y's, so I just solve for x. So this would be 6x plus 8x minus 40 equals 1. Combine like terms and I get 14x. I'm going to add 40 to the other side, so I get 41. So x is 41 over 14. Okay, then to find y, I can plug it back in. I'm going to use my rearranged equation, so 2x minus 10, so y would be 2 times 41 over 14 minus 10. You can use a calculator. And then, so for y, we get negative 29/7. And so our solution would be 41/14, negative 29/7. So that is what you would do if you are trying to use substitution. Again, I would suggest using substitution if you have an isolated variable. If everything's lined up like it is on this one, I would do elimination. So I'm going to show you same problem, but we're going to do elimination. So when the x's, the y's, the equals, and your constants are all lined up, elimination is usually the method you want to use. So you can see that in my top equation I have negative y, and in the bottom equation I have positive 4y. So I'm going to multiply the top equation by 4. That would give me 8x minus 4y equals 40. Then I'm going to keep the bottom equation, 6x plus 4y equals 1. That's going to eliminate the y's, and I end up with 14x equals 41. Divide both sides by 14. I get 41 over 14, which we know from doing it using substitution, that's the correct answer. Then you have to plug it back in just like with substitution. So 2 times 41 over 14 minus y equals 10. So this would become 41 over 7 minus y equals 10. Take 10 minus 41 over 7. You get negative y equals 29 over 7, which means y is negative 29 over 7. And we know those answers are correct from our previous method of solving. But again, I feel like elimination's a little bit easier in this case because everything's already lined up ready to go for you. Okay, our next example is solving a nonlinear system algebraically. So for these, substitution is probably going to be the best, easiest method for you to use. So we have both of these equations are set up as y equals, so I can take the 8x, substitute it in for that y. So 8x equals x squared plus 6x. I'm going to subtract it all to the same side because it's a quadratic. So this would be x squared minus 2x. I have no constant, so I can just factor out GCF, factor out an x, times x minus 2, which means that x equals 0 and x equals 2. And so this solution, we're going to have that means we're going to have 2 points where these two graphs intersect. So we now need to plug both x's back into either equation to find our y. So I'm going to use the bottom one. So y equals 8 times 0 is just 0. So one point of intersection is at 0, 0. And then y equals 8 times 2 is 16. So the other point of intersection is at 2, 16. So that's how we solve nonlinear systems. Okay, then our last two examples are no solution and infinite solutions. So again, if I was solving this, it's set up for elimination because everything's lined up. So I'm going to multiply, let's say I want to cancel the x's. So I would need to multiply the top equation by 2. So that would be 6x plus 4y equals 10. And we have negative 6x minus 4y equals 10. So when I did that, accidentally both of my variables cancel, which means I have 0 on the left, and 10 plus 10 is 20. So 0 equals 20 is a false statement, so that means that my answer is no solution. So variables out, not no solution. There we go. If your variables cancel out and it's a false statement, then it's no solution. So here, similarly, okay, I'm going to use elimination. I'm going to eliminate, let's focus on the x's again, so I'm going to multiply the top by negative 3. That becomes negative 9x minus 18x equals positive 30. Then we have 9x plus 18y equals negative 30. I think did I say that? Did I say the first one wrong? I'm not sure. Anyway, x and y. Okay, then I'm adding this together, and again, both variables cancel out, so I'm left with 0 on the left, and then 30 plus negative 30 is also 0. So 0 equals 0 is a true statement. So when your variables cancel out and you're left with a true statement, that means that there are infinite solutions. Okay, so that is kind of a review of how we solve systems with two variables. Let me know if you have any questions.